In this section, we're going to talk about molar mass. And what I've prepared here is I have three different pure substances. I have sulfur, I have copper, and I have sucrose, which is sugar, cane sugar. And I have 1 mole of each of these substances. And what you will notice is that even though I have 1 mole, which is how many particles of each substance? 6.02 times 10 to the 23rd. They all have different masses, okay? So the sulfur has 32 grams in 1 mole. The copper has 63 grams, and the sugar has 342 grams. What we have to remember is, I told you before that 6.02 times 10 to the 23rd is kind of like a dozen of donuts. So I have 1 mole of each of these, which is like 1 dozen. But when we're considering the mass of different objects when we use the dozen analogy, for example, if I have a dozen chocolate-covered strawberries, they have a different mass than a dozen donuts. And so it's the same idea here. Even though I have the same number of particles for all of these, the different particles have different masses. And so that's why these each have a different molar mass. So I'll put my notes up here, and I'll give you a few seconds to pause and copy those down. So we're working on section 9.2, molar mass. Molar mass is the mass of 1 mole of any pure substance. So this pure substance could be an element. It could be a compound. It cannot be a mixture. That is not a pure substance. Now we're going to see that for 1 mole of a pure substance, we can look at our periodic table and see that we can use the value for the atomic mass unit to mean 1 gram. So for instance, an example would be if you look up carbon 12 on your periodic table, you will see here is carbon. There's the 12. Its atomic mass is 12 atomic mass units. That's the mass of 1 atom. It's also the mass of 1 mole if we put the label gram on it. And so that is how I came up with the value for copper. My 63 grams of copper comes from my periodic table right here where we see 63.5. So really I should have 64 grams, but probably when I found the mass of these, my pennies weren't quite that. But it's close enough. And the same for the sulfur. My 32 grams of sulfur comes from my periodic table right here where sulfur, the atomic mass is 32. Instead of writing a U after it, I just write a G for grams. And we're going to find that the mass of a known substance can be converted to moles by using the molar mass of that substance. So let's do some problems. I'll give you a few seconds to pause the video and write these problems down. Okay, so let's say I want to find the mass of half a mole of helium atoms. I start with my quantity here, half a mole. Now remember, we're going to be using bridge notation, and we also have to pay attention to our significant digits. So I write down my 0.5000. Don't drop those zeros because they are significant and we'll need them later for our answer. So I write that down, and I want to go from moles to mass. Well, how I do that is I now know that 1 mole of helium, that number can be found on my periodic table, is equal to a mass of 4.00260 grams. So I write down 4.00260 grams of helium. Now I know this works out because I can cancel my units there. Those cancel on the top and the bottom. My units that I'm going to label my answer with are here. And when I multiply 0.5 times 4.00260, I get 2.001 grams of helium. Now I know that you got more numbers than that in your calculator when you did that, but I need to pay attention to my significant digits. And here, this number, remember, has 4 significant digits because zeros after the decimal are significant. So I have 4 significant digits here, and I have 1, 2, 3, 4, 5, 6 significant digits here. When I am multiplying, I have to go with the smaller of my 2 significant digits. That's why I have 4 significant digits in my answer. So I'll pause for a few seconds if you need to write down the next question. So another way we can use this is we can now say how many atoms are in 4 grams of copper. So I'm starting with 4 grams of copper. So I write down what I know. But I cannot go directly from grams to atoms. I don't know how to do that, but I know how to go from grams to moles and then from moles to atoms. So I'm going to have 2 steps here. So if I look up on my chart, I know that 1 mole of copper, I look up in my periodic table, is 63.546 grams. So I have to put the 63.546 grams of copper on the bottom so that it will cancel. It wouldn't work if I put moles on the bottom. Then I can go from moles to atoms because I know that 1 mole of copper contains 6.022 times 10 to the 23rd atoms of copper. And when I do the multiplication across and the division, and oh, I better cancel out my units there. When I do the multiplication across and then divide by 63.546, I get, I'm going to write the answer down here, 3.79 times 10 to the 22nd atoms of copper. Now again, I have 3 significant digits here because I have 3 significant digits here, I have 4 significant digits here, and I have 1, 2, 3, 4 significant digits here. And so I have to go with the fewer of the significant digits. Okay, to practice this further, let's do some problems from the book. These are found on page 227 in your textbook. We're going to do numbers 2 and 6. So if I take a look at problem number 2, it says, how many atoms are found in 600 grams of iron? So I have 600, don't forget the decimal point, grams of iron. The decimal point needs to be there because that makes those 2 zeros significant. And so what I have to do here is I want to know how many atoms are in this. So I have to first convert to moles. And so 600 grams of iron, I have to figure out how many moles of iron that is. Well, I can figure out the molar mass because I can go to my periodic table and see that it's 55.845 grams. So I put that on the bottom. That crosses out. That is equal to 1 mole of iron. And I know that 1 mole of iron, putting it on the bottom so it will cancel out, is 6.022 times 10 to the 23rd atoms of iron. And so when I do that multiplication, I get 6.47 times 10 to the 24th atoms of iron. Always remember your label is that last, whatever appears here, last in the line that we don't cross out. So going to number 6, the question is, how many moles of atoms are in 1 pound, which is 454 grams of lead? So I have 454 grams of lead. Oh, I also forgot to mention in this problem, I have 3 significant digits here in the answer because I have 3 significant digits here. I have 4 here, and I have 4 here, so I always go with the fewest. So I have 454 grams of lead. And I want to know how many moles that is. I know that the molar mass of lead, let's see, PB is right here, is 207.2 grams. So I write that on the bottom so I can cancel out my units. Those cancel. That is equal to 1 mole of lead. So when I do the division, 454 divided by 207.2, I get 2.19 moles of lead. And again, 3 significant digits here, 4 here, so my answer must have 3 significant digits. I will be going on to the next video here after this, so you have one more video and then it will be time for some homework.